Ellington, how are you doing today? Welcome to week 3. We're going into phase 3 of our project. A lot of things going on this week with phase 3, building out this network, add another floor, we've added buildings, and we're just going to keep this thing going. I tell you what, let's get into this, but first I want to just do a short review of where we came from, right? So we started with phase 1. Okay, this project, we're building a network for a building for the floors. We're adding floors, we're adding buildings. The first week, what did we do? We started with a basic network where we had one router, 2 subnets via 2 switches, and this was the accounting department and the executive department. If you remember, we subnetted. This is where we started doing subnetting, and we did basically static subnetting, where we took our IP address we were given, 172.16.x, and in my case, I'm using 10 as the for the third octet. So .10.0 CIDR 24, and so we subnetted that into 8 8 equal subnets, right? They're incrementing by 32, if you remember. So then we took the first 2 subnets and we assigned them to our accounting and our executive department. And this is how we set up the interfaces, right? So we took the IP addresses that we figured out here, 172.16.10.0 for the first subnet, first host being 1, last host, assignable host was 30, and our broadcast was 31, and we assigned that to the accounting subnet. We took our second subnet, which was 172.16.10.32, and we assigned those 32 IP addresses to the executive subnet, to the second subnet. That's what we did basically in week 1. Then moving into week 2, well, we stepped it up a little bit. We did a couple things. One, we now started using Vlsm, variable length subnet masking. And what that does, like I say, it allowed us to become more efficient with using our subnets and using our IP addresses. And that way, instead of subnetting at an equal increment, like at 32, now we're able to subnet based on the number of IP addresses we needed per subnet. And we added a second building, right? A second building. And with that, we had to add a second router, and then we had to have a route between router 1 and router 2 so that those 2 routers could talk to each other, okay? So everything else was still pretty much the same. So once we went through, we've already gone through this, but we went through the how to do your VLSM, and we broke out the subnets again, as well as we had some left over for expansion if we needed them. And I had questions of, well, why do we use 200? Well, the reason we use this 200 down here is really for a way of just pushing back the IP addresses for our routers toward the end of the IP address schema. So that way it makes it easier to identify what they are. Now, also, you notice what I started doing in week 2, because we're getting more subnets, I started color coding these. And what it helps me is to stay organized, having good tables, good documentation of your IP addresses. Also now, like I say, the blue corresponds to the engineering subnet, yellow to the IT subnet, and so on. So that way the color codes kind of match. So that way we know as we're assigning IP addresses, we know where those went. So that's what we did in week 2, okay? Now, also in week 2, like I said, what we did, we started talking about static routing, how to build routes between those 2 routers so that these 2 routers can talk to each other. If these 2 routers are not talking to each other, or within their databases, they don't understand that how to connect each other, this subnet would not ever be able to talk to this subnet. Now, these 2 could talk to each other, but anything between the routers, any intra-router communication wouldn't happen. So when we talk about subnetting, I'm going to show you 2 things we did. What I call a default static route and a more defined static route. So when we think about these static routes, here again, we start with our same network, right? We've got our subnets, we've got our routing subnet, and we want to be able to set up a default static route. So what we can do, actually, right in Packet Tracer, once you've gone into your, excuse me, to your configuration mode, global configuration mode. Now we can just set up an IP address, IP route 0.0.0.0 space 0.0.0.0, and tell it which port, which interface you want to put that on the 0/1/1. And we're working with this router right here, okay? So what this will basically do is set up a default route, meaning that any IP address with any subnet will be able to pass through that router. So that's what a default subnet would look like. So now if I go into that router and I pull an show IP route, this is what it's going to show me, okay? If you remember, you have C, which are connected routes, and L are local routes. So the ones I'm going to focus on are the connected routes, okay? And this time you're going to see another one is the S, and S means it's a static route. And when you see that S with the little asterisk, that's telling you that is the default static route. So when I look at this now, this is telling me, what is this telling me? It tells me that I have a connected subnet, a connected path on this interface, on the 0/0/0 interface, which is my 10.64 subnet. Okay, it also tells me that on the 0/0/1 gigabit internet interface, I have another subnet, the 10.96 subnet. Now, something else that it tells me is very important is it also tells me that right here, okay, I have a subnet that shows that there is on the serial 0/1/1 that there is a subnet right there. Okay, so now I know all the connections on that router that have something attached to it. Then it also tells me that interface connects directly to this interface. So now if I want to be able to talk to these subnets, it knows how to get there. So anything can pass through. So that's what this is showing me with a kind of that default subnet. Now, how we would typically do this, though, is more in a defined routing, where I'm going to actually define the route paths. So if I got the same diagram, okay, now what I'm going to do, I'm going to change routers. Okay, in my corporate office router, I'm actually going to define 2 IP routes. Now, what these IP routes are telling me is that it's basically I'm just building a database inside of that router. That's all these IP routes, and that's all we're actually doing is building a small database inside of these routers so that router knows how and who it's talking to. So what it's saying is that, okay, I've got I need to have it for this router. It wants to know how to have a route to get to these subnets if it wants to talk to it. So the first one, that's what it's telling me, that I'm going to establish an IP route from 172.16.10.64 255.255.255.224. So basically what it is doing for me, it is establishing a connection to this, or a pathway to that subnet. The second one that I'm going to put in there would be 172.16.10.96 with a subnet mask of 255.255.240. And they are connected to the 0/1/1/1 interface here. So this is what this is doing for me. So let's take a look at what now, when I run my IP route, if I show IP routes, so it's going to show me a lot of the same things, but now you see I have 2 static routes defined, okay? So this static route tells me how I can get from this router to that subnet, that there's a routed path that goes from 172.16.10.64, and it's directly connected from the 0/1/1/1 interface to the 0/1/0 interface on that router. Very similar. This is the path that would get me to this subnet. which is the 172.16.10.96. Also, it tells me that interface right there, the static route between the routers. So it shows me all those different interfaces. So now, let's say if I have two computers who want to talk to each other on different subnets. Let's say this computer right here, which is on the .10.0 subnet, wants to talk to this machine that's on the .10.64 subnet. How does that happen? Well, let's use Traceroute to help us with this. So the first thing that's going to happen, you see that there's three bounces if we look at our Traceroute that happens. The first one is right here. It starts with, that's how it's going to do a ping. Well, that ping is first going to go through the switch, and it's going to hit this interface on this router. And then this router is going to look at that and go, okay, you want to get to the you are trying to ping the, this IP address up here. Let's say that is IP address 66, 172.10.16.10.66. Well, first of all, it knows that, excuse me, it is not a local route. So now it has to figure out within its routing table how to get to where it needs to go. So it looks at its routing table and says that you're trying to ping 172.16.10.66. Let me see if I have a route already established to that subnet. And it looks up here and said, yes, I do. Because that IP address falls in the range of 172.16.10.64 CIDR 27. And to get there, I've got to go out of my 0/0/1/0 interface. So then that's it. It sends it out of that interface, and it knows to go to the building 2 router. And once you get to the building 2 router, that router looks at it and goes, oh, you're trying to get to 16.10.66? Yeah, that's a local path for me. And it shoots it right over there and right out, and that's how it gets there. So that is what this routing table is saying. It's saying that if this computer wants to ping that computer, this router now has to have a route established to be able to get to this router, which now this router knows it is a local delivery. Very similar to what? You got it, our US mail system. Routing. This is your local post office, comes in here, says, okay, I can't deliver it. Well, I need to route it to another router or to another post office, because it's looking at the zip code. That's a different zip code. Let's send it to this router because I know where that router is, or that postal hub. And once it gets there, it says, yes, that's a local delivery for me, and it sends it to the house. That's really all routing is, just like the local mail, just like mail delivery. So that is how we do define routes, okay? So that we actually now build an actual table. But this is all, both of these are static routes. And this is what we did in week 2. Now, going into week 3, I say that was a pretty extensive review, wasn't it? Of week 1 and 2 of the project. But I want to be sure that we understand what we're doing with the project each week and how we're building and how we're adding new capabilities and protocols. So week 3, what are we going to do? We're going to add a second floor. And this second floor to building 1 is going to have all these components. We're going to add a sales department and a marketing department, okay? And these are the computers, printers, servers that are in each of those departments. And to do that, we're going to have to add another router, and we're going to have to add 2 more switches to build this out. Now, we're going to add something else this week as well. So far, all of our PCs have been static IP addresses. This week, we're going to change them to DHCP, Dynamic Host Control Protocol, where they can automatically pull an IP address from a DHCP server, okay? So we're going to add that in as well. So this is what our network's going to look like this week, okay? So we're here to the center. I'm really going to focus here a lot, excuse me, because these are the 3, now we've got 3 routers. Before we just had these 2 routers connected. Now we got a 3rd router that's going to be on another floor in this building. So this is one building, this is another building. These 3 routers are connected together, and now you see we have multiple subnets, okay? So if we look at our subnets, we got accounting, we got executive, we got engineering, we got an IT subnet, we have sales, we have marketing, and don't forget, we've got all the routing subnets. So we got quite a few subnets going on in here, right? So be sure you mark and capture all the subnets, especially these 3 subnets right here, because you have to allocate IP addresses for those. And here again, Stan uniform with your documentation is extremely important. So to help you out with that, this is how, and it doesn't mean you have to do it this way, but this is just how I kind of lay this out so I can understand where I am with respect to doing our subnetting. Excuse me. And you'll still be using variable and subnet masking, okay? So kind of color code everything. Yeah, these are the accounting and executive subnets. This is what floor they're on the building. It's building 1 on the first floor. This tells me how many hosts I need. I need 13 hosts. And with Vlsm, to get 13 hosts, I have to subnet with a CIDR 28, which will give me 16 hosts. And then from there, here's the first network ID, and here's my 16 host assignable IP addresses for that first subnet. Second subnet, again, it's on the first building, first floor. I need 23 hosts. To get 23 hosts, we're using Vlsm. I had to use a CIDR of 27. That gives me 32 hosts. Okay, that's how I'm able to get 23 out of those 32. Where do I start at? I start where I stopped before. I stopped at 15. I'm going to start at 16. And from 16, 32 will take me to 47, 10.47. So, and that is how I lay out all of my IP addresses, and I do my Vlsm subnet masking. Sales and marketing, they're in the same building, but on the second floor. I need 23 hosts for sales and 13 for marketing. So I'm going to Vlsm. I'm going to subnet with the CIDR 27 and a CIDR 28 to get those. And you see the process keeps going. And then this is the engineering and help desk, which is in the second building on the first floor. And I just continue doing the same thing. Now for those 3 routing subnets. So the subnet from router 1 to router 2, I need 2 hosts. So I'm going to CIDR at CIDR 30, which will give me 4 hosts. Now, you see what I do here? I skip down. If you notice my last IP address I used up here for all my room subnets, the last one stopped at 95. So I could have started here at 96, but I didn't. We skipped down to 200. Why? That leaves a lot of room in here for expansion. Let's say if I want to put another a second floor on my other building, I can start that with 96. So skip down to 200. That's where I started with my routing subnets with 200. They're all going to be in the 200 range. So the first ones, I need 2 IP addresses, which would be 201 and 202, and my broadcast 203. And if you notice the subnet mask for that's going to be what? You got it, .252. So I do that for all 3 of my router subnets. I have a subnet from router 1 to router 2. I have a subnet from router 1 to router 3. And I have a subnet from router 2 to router 3. Each one of those needs 2 IP addresses for that route, one for each end of the route each interface on each end of the router. So it's going from 200, 201, 202, 205, 206, 209, 2010. Those are the IP addresses I'm going to assign to these routers. Okay. These routing subnets, router 1, router 2, router 2, router 3, router 3 to router 1. Okay, hope that makes sense. If not, hit the rewind button, watch it a couple times. If not, then give me a call or email or text. All right, so that's how we do our subnet masking. Now, something else we do differently in week 3. We no longer do static routing. Now we're going to go to dynamic routing. There are multiple dynamic routing protocols that we could use. However, for this class, we're going to use Eigrp Enhanced Intergateway Routing Protocol. Okay, but there are several. Open Shortest Path First, Routing Internet Interchange Protocol, RIP. There are multiple protocols that are out there that could be used, but we're going to use Eigrp. Okay. So let's talk about the Enhanced Interior Gateway Routing Protocol for a second. And why they call it an Interior Gateway Protocol is because when we think about large networks, this is one that's on the interior of our network. It's not one that's talking from, like say, one of the large networks to another large network. We have, excuse me, other protocols that do that. So what it does with EIGRP, what it does, it shares routing information with its neighbor routers. So when a new neighbor is discovered, EIGRP automatically reaches out and it learns the database that's in its neighbor routers. Great thing about EIGRP, it supports a Vlsm as well as it supports CIDR, IPv4, and IPv6, okay? So what happens with EIGRP? First of all, it builds within itself a neighbor table, like I say, where it learns all of its neighbors and it lists all of the directly connected neighbors. So if you got two routers that are directly connected, it lists that in its table. And then from there, it lists what they call the next hop router. Meaning, so if I want to get to this place right here, I've got to go to this router or hop to this router to get there. And it knows all the interfaces. That's all listed in the table. It also learns the different metrics. I mean, how the electrical distance and the electrical or the logical quality of the link. Meaning that even though I may be connected from router 1 to router 2, and router 2 to router 3, and router 3 to router 1, it may be quicker for me to go one direction than it is the other. Just like if you live, I live here in the Dallas area, right? Even though it may be shorter distance for me to go across from Dallas to Fort Worth using Interstate 20, but that may be the most congested path, whereas I may want to take the Beltway and go around the other direction, just by knowing, even though it may be geographically closer, but because of congestion, it may take me physically longer to get there. Well, that's what routing protocols do as well. They are able to determine how long it's going to take to get to their neighbor routers and use the shortest path to get there, or the least congested path. And it's established global routing tables. Like I say, it figures out the best route based on the topology. I mean, you could have 3, 5, 15, 20, it could be multiple routers in your network. Now it's going to figure out what is the best path to make it through all those routing, throughout those different routers. So that is, kind of what EIGRP does overall. So when we think about an EIGRP routing table, this is kind of what we're going to look at. So this is our network that we've got, right? The same network. I know it's pretty small right there, but I'm going to send you the PowerPoint so you can look at this a little bit closer. But really just focus right here, because this is what we're going to be talking about for the most part, of how EIGRP builds routing tables. Now, how do you actually build a route? Well, pretty simple. Same thing in Packet Tracer. What you're going to do, you're going to, once you can go into the configuration mode, you're going to just type in router EIGRP, and you're going to give it a number, like 100. That number doesn't really matter. Only thing that's important is that all the routers in your the neighbor routers have to be in that same pool, in that same EIGRP pool. So for this example, I'm just going to use EIGRP 100. And then you're going to identify the network associated with that routing pool. So then, because once you type that, now it's going to take you to another cursor, which is config-router. Now, what we're saying here is that this is going to be the network. 172.16.0.0. Basically, any router, it doesn't matter what the last two octets are, but any router that's in here is going to be a neighbor router. Any router within that IP range of 172.16.0.0, any router in there it will look at as a neighbor, as long as it's in the same pool. So that's what we've built. We've built this route within our table. Now let's pull the what we did here in Packet Tracer on that router. We're going to show the IP route. And now, if you didn't realize you could do this, yes you can. So when you show IP route, if you just put like EIGRP at the end, you will only get the EIGRP or the dynamic routes. If I had just put EIGRP route without, IP route, show IP route, it would have given me the local ones. It would have given me the connected, static, long list. I didn't want to see all those. I only wanted to see the dynamic routes. So I'm just going to put EIGRP. You could put, anything else after here, remove EIGRP, and you could put connected or static, and it would only show you the static routes. So these are the dynamic routes, okay? So basically this is, once we loaded this right here into all three routers, they got to be into all the routers, then it built a dynamic table where all three of these routers learn each other. So what I'm looking at here is actually just one router, right? I'm just looking at this corporate office router, that one right there. So that's what I just pulled that from. So what is this showing us? Okay, what is this showing us? This is saying for this router that now it has learned the paths to all these other routers. So let's take a look at this. So let's break this down and see what this is actually showing us. Okay, this first part, this is the destination network, meaning that so if I want to get to this network right here, which is the 48 network, right? Well, this right here, that tells me how to get there if I'm from this router's perspective. So that right there is the destination network. This is remember I talked about that it could determine the administrative distance and the metrics. That's what that is. The administrative distance is a 90. The metric is how well or congestion level. Okay, and now how is it going to get there? This was the next hop router. So to get to the 48 network, excuse me, it knows that to get there, it's got to hop that to this router, and this router will get me to that network. And the last one is the outbound interface. So to get there, it's going to have to go out of interface 0/1/1 to get here, to get to these networks. So let's take a look at how this works. So let's say this computer right here wants to talk to either one of these two computers on these subnets. How is it going to get there? Well, here's what happened. And these are Eigrp routes. So basically, yeah. So this computer hits this router. This router knows already that it has two routes established to get to the .48 network and the .64 network. .48, .64. To get to either one of those, it knows that it has to go to the .202 subnet, which is right here, right? And it's got to go out of its own interface 0/1/1. So that is how this router, this computer would come to that switch, go here. It sees that routing table, and it routes it to this next hop router, and that next hop router will then send it to where it needs to go. Likewise, if this computer wants to talk to these two computers, okay, over here on these two subnets, well, if you notice, it changes, right? So to get to the 96 and the .96 and the .128 subnet, it's going to have to go out of this other interface on the router. And then it's going to go down the .210 subnet, which is this one right here, which will then take it over to those two subnets from these routers. So this is how those routers all talk to each other. And the third thing you see there, oh, sorry about that, is it also knows how to get to this subnet. That's what these two are. And you see, notice it just has one destination network, but it shows you two paths. So what this is showing you is that there are two ways to get to this .204, which is this little subnet right here, meaning that it can go this way and get there, or it can go this way and get there. That's what these two different individual paths are right here. Two ways to get to this subnet. You may say, well, why is that important? Here's why. Because you think about this right here. Think about this little number that we're looking at right here, which is the metrics and distance. Let's say that if this computer wants to talk to that computer, but that leg right there is broken or it's highly congested. Well, now, see, if you had just done static routes, well, it would have gone there and it's like, oh, no route, can't get there. So, but dynamically, now it goes, I can't get this way, but guess what? I know I can get here, and I know I can get here, and now there. So it will automatically take this traffic, route it, reroute it. Even though, if you look at the over here for these two routes, you see the metric's pretty high. That's why it's going to always select this path first, unless this path doesn't exist, or the metric for this path gets to become higher than that. That's a very high metric. So let's say if this path was broken, this cable, this Cat5 cable went bad. Well, that metric is going to go to infinity, which means this is the shortest metric now to go from this router to that router to that router, and then that router now can send it to where it needs to go. So that is, EIGRP in a nutshell. That's what we're talking about with a dynamic routing protocol. Now let's say if I added a fourth router in here, I had another network and put a fourth router. If I configured it with an EIGRP 100 group, and I put the same thing, 172.16.0.0, these two routers, which are the neighbor routers, they would learn that routing, the table in that one, and now they all four would be able to talk to each other. So that is in essence what dynamic routing is doing for us. And that's what we're doing in week 3. You'll be setting up a dynamic routes between your routers. Now to do that, you got to remember, you have to take the static routes out of your network first. Remove the static routes, and then you'll be able to load the dynamic routes. Now, the last thing we're doing this week also, like I said, we're throwing a lot of stuff at you this week, is Dhcp. So what you're going to have to be able to do now is you're going to take one of these servers right here, just to do, I'd say the engineering server. Let's take the engineering server, and you're going to make it a Dhcp server. So basically, you're going to go into the into the services tab up at the top of that server, and you're going to go into Dhcp. And what you're going to do is build Dhcp pools. And these pools is going to be related to each of the subnets. For instance, if you notice when you build this out, well, let's start at the top. This is kind of built in 2 sections. This top half, this is how you actually will actually build the server pools. You're going to build those by establishing the name of the pool. For instance, this one is the engineering, and basically you're going to use the name of each of the subnets. The default gateway for engineering is 172.16.10.49. Now the DNS server is the IP address of this server, which is 172.16.10.2. Okay, so now this is where you're going to use what is going to be the starting IP address, meaning this is where you want the Dhcp server for this pool to start handing out IP addresses. And for this particular one, since it is the default gateway is 49, we're going to start our IP address at .52. And let's go for, and you need a maximum, how many users? You need a maximum of 11 users for this particular subnet. So it's going to start at 52 and go all the way to 61 and hand out IP addresses automatically. So that's what you're going to see. Now, when you finish down at the bottom, this gives you like a summary, and you got to always remember to hit save, and then you can continue to make. You need to make a Dhcp pool for each of the subnets. For every subnet, you would need to have a Dhcp pool built, which should have your default gateway for that subnet. The DNS server, so that doesn't change. That's going to be the .2 all the time. The starting IP address, that's going to be different based on the default gateway for that subnet, as well as the subnet mask and the number of users. So there you have it. So that's what we got going on this week. Like I say, have fun with it, guys. Have fun with it, because there's a lot of moving pieces. We're going to be, adding another floor to a building. We're going to still be using Vlsm. Also, you're going to be adding in dynamic routing and Dhcp. Whew. I'm tired just thinking about it. All right, if you have any questions, y'all, as always, reach out, email, text, whatever method, and we'll try to get your questions answered. Have a great week, and we'll see you.